solve dy by dx plus 5y equals 3 for y, given that y of 0 is equal to 3. Okay. Now, in this case, this is a differential equation. Oh, looking at it, is a differential equation. So here, remember the general form of some differential equations would be dy by dx plus py equals q, right? And the integrating factor is e to the integral of p dx. Then you multiply by the integrating factor, right? You multiply by the integrating factor. After that, you use the reverse product rule, and then you integrate both sides of what you have there. All right, so I want you to write this down, go ahead and work it out. Now, I worked it out before. What I got was y equal 3/5 plus 12 over 5 e to the negative 5x. That's what I got. So, provided I didn't make any mistake, you should get the same thing if you work it out correctly. So go ahead. Okay, you finished working it out? Let's work it out together. So dy by dx plus 5y equals 3. dy by dx plus 5y equals 3. Now, if you compare it to the general form, dy by dx plus py equals q, you see that p is equal to 5 and q is 3. You see that? Now, the integrating factor is e to the integral of 5 dx. So, the integrating factor then is e to the, when you integrate 5 with respect to x, you get 5x, right? And the next thing, multiply both sides by the integrating factor. So you have e to the 5x dy by dx plus 5e to the 5x times y, right? Equals e to the 5x times 3. All right, so that's what we have there. Now, you next use the reverse product rule. What that means, what you have here is the result of differentiating something, some product. Remember what the product rule says? Is that if you have the derivative, I'm going to leave off the dx part. If you have the derivative of uv, where u and v are functions of x, what you get is the derivative of uv is you whole u times find the derivative of v plus you whole v times find the derivative of u. Alright? That's the product rule. Oh boy. Alright. The product rule there. I beg your pardon there. Now, it means that if you go from here to here, use the product rule, but going the other direction, you use the reverse product rule. Looking at this mean you hold u and differentiate v, plus you hold v and differentiate u. So you have differentiated uv. Now here, it seems like you hold e to the 5x and differentiate y. See? And here you hold y and differentiate e to the 5x. When you differentiate e to the 5x, you get 5e to the 5x, right? So here, you're looking at the derivative with respect to x of, what did you hold here? You hold e to the 5x. So one of the things is e to the 5x. And here, you hold y. So it's y e to the 5x. If you should differentiate this, let me put it in bracket. If you should differentiate this, what you get is you hold e to the 5x, differentiate y with respect to x to get dy by dx, multiply them, plus you hold y times differentiate e to the 5x with respect to x, you get 5e to the 5x. See that? And then that is equal to e to the, let's put the 3 first, 3e to the 5x. Alright, so remember the next thing you do, integrate. When you integrate, integral of the derivative with respect to x of ye to the 5x equals the integral of 3 e to the 5x. So it's dx, right? You're integrating with respect to x, so it's dx. Now, integrating, you have 3, you can put the 3 on the left of the integral sign, so you don't have to concentrate on dealing with it, right? Alright, now, when you integrate a derivative, integrate with respect to x, and integrating a derivative with respect to x, the integral and the derivative cancels out, leaving whatever function you're integrating and differentiating at the same time untouched, right? So you have y equal, no, oh my gosh, you have ye to the 5x untouched, it's undisturbed. And you have equal 3. When you integrate e to the 5x, now if you have been doing a lot of integration by substitution, you'll be able to do this mentally, but assume you haven't been doing so. Just look at how you deal with this. Now, if you look at this, say let u be equal to 5x. So what you have is the integral of e to the u dx, but you want du. So du by dx is equal to 5. So that means dx is equal to du over 5, right? So what you have is the integral of e to the u du over 5. Same thing as 1/5 integral of e to the u du. When you integrate e to the u du, what you get? You get e to the u plus c, right? So this is just a substitution part. Let's cover it up. Alright, so here we have ye to the 5x equal 3 times 1/5 e to the u plus c. But remember now, you had been given a function in x not u, and u is 5x. So let me remove this and put 5x, alright? Now, after that, you divide by e to the 5x. So y e to the 5x over e to the 5x, you know, e to the 5x will cancel itself, so you have y equal. This will be 3/5 e to the 5x over e to the 5x plus c over e to the 5x. This will cancel itself too. So you have 3/5 plus c e to the 5x. No. Oh, alright, you can just, alright, let me rewrite it. Over e to the 5x. Yeah, c over e to the 5x. What was the initial condition again? Y of 0 equals 3. That means when x is 0, y is 3. So when x equals 0, y equals 3. So what you have is 3 equals 3/5 plus c over e to the 5 by 0, which is 0. So the initial condition will allow you to find the constant of integration. So this will be 1. E to the 0 is 1. So c will be equal to 3 minus 3/5. Oh no, why I put this under here? It's 3 minus 3/5. C is 3 minus 3/5. What would that be now? If you multiply the top and bottom by 5 to get common denominators, something over 5 minus 3/5. This is 3 over 1. 5, 1, 5, 5, 6, 15. So 15 minus 3 is what, 12/5, right? So C is 12 over 5. So what you have is y equals 3/5 plus 12 over 5. This could be written as e to the negative 5x, right? That's what I say I got. Y equals 3/5 plus 12 over 5. Y equals 3/5 plus 12 over 5 e to the negative 5x, right? So that is what I got. Did you get it? Well, if you didn't get it when you tried it on your own, I want you to try it again without looking back at the solution I have here or any other solution. So write the question down and make another attempt at it, right? Ensure that you get it. Alright, so I will see you next time.